My name is Belen Bermejo. I am part for the University of the Balearic Islands in Spain, and I'm gonna present a research work which is titled Performance in Server Consolidation. This research work is performed by the Professor Dr. Carlos Juiz. So let's start with some interesting data, with some interesting facts. The first one is that the greenhouse gases comes from IT right now are reaching the 7% of the whole of the total in our planet. So since this fact is it's important to consider the organizations, IT organizations, cloud organizations started to be concerned about the impact of the IT on energy consumption. Also, it's important to know that from these 7% of greenhouse gases, the 50% comes just from the data centers that all we know. In the same manner, in the data centers, the most power demanding device are servers. So it's clear that we need to put attention in the servers that are in the data centers. In order to mitigate this impact of the energy consumption in data centers, the Green IT appears several years ago as a set of different good practices and techniques, and one of them was the server consolidation. The server consolidation is based in a very simple technique, which is to allocate the maximum workload in the minimum number of physical servers. Considering the data centers we have right now, this workload should be virtual machines, containers, Kubernetes, all the time of virtualization technique. So if we are able to put in the maximum workload in the minimum number of physical servers, we can save in power consumption because we can switch off several physical servers from the data center. But on the other hand, we have a performance degradation because if we are putting more workload in a lesser number of physical servers, we are demanding more resources. So the question here is, what about the energy consumption? If we have one saving on the one hand and a performance degradation on the other hand. So considering all of this background, together with that, the energy savings in this case are not compensated with the performance degradation. The challenge here is how to determine if the consolidated server is efficient or not in terms of energy consumption and performance degradation. So the research question here is, could the performance and energy trade-off of physical servers when consolidated virtual machines be quantified? So we have on the one hand the performance of the servers on the one hand, on the other hand, the energy consumption, and in the middle we have to find a trade-off between this performance, that at the end is the quality of service, and the energy consumption. So this research work is the first attempt to define a metric in order to quantify this performance and energy trade-off. But here the novelty is that we consider the server consolidation. That is, we consider the number of virtual machines and the number of containers, Kubernetes, whatever of technology we are using for the consolidation. So this is the novelty of this work in some sense. This metric is the THIS index, which is our main contribution. THIS comes from the consolidated index for CPU server saturation. You can see here that the formula for the calculating the THIS index is simple, but we need to apply some monitorization techniques as we will see in the next slides. But the most important part here is that we consider on the one hand the performance and on the other hand, the energy consumption. So in just one metric, in just one number, we can put the behavior of the performance and the behavior of the energy consumption. One of the most important parts of this index, a part of the single number, is the graphical representation that you can see here on the right part of the slide. We can represent, considering the number of machines, in this case, the number of consolidated virtual machines or containers, we can obtain the THIS index. This THIS index, depending on the part of the graphic we are considering an inefficient consolidation or efficient consolidation. For example, if we have 3 virtual machines here and our THIS index is on the green part, we have an efficient consolidation. But if we have this index on the red part, our consolidation is inefficient, and in this case we should modify the number of virtual machines or the distribution of the virtual machines among the servers in the data centers. So this graphical representation allows the system administrator to distinguish the efficiency in a server consolidation degree. This part is important because if we have some inefficient behavior in our data center, just with one number and just with one graphic, like you can see here in the slide, is very easy to reconfigure our virtual machines or our containers. In order to demonstrate that our index is useful in data centers, we perform an empirical evaluation based on real experimentation, in which we consider several factors. We vary the hypervisor type, we prove different benchmarks, and we use different servers with different hardware features. Here it's important to know that we use a black box model in order to simplify the different factors we consider. So we just submitted the workload in the different physical servers, and we just wait until the workload is completed. Considering the experimental setup, we use a physical power meter, we use different hypervisors, the KVM, VirtualBox, and Docker. We vary the number of virtual machines and containers, and here one of the most important parts is that we vary the different physical servers. We have a set of physical servers with different number of CPUs and different size of memory RAM. This set of physical servers allows us to prove our index in several scenarios. Considering the most important result from our experimentation, we see that these values depends on, first of all, the hardware we have in the server. But as you can see in this picture here, in this graphic here, all of this index has a very similar behavior. They started increasing and then go down. That is, if we have a more number of virtual machines, we have more efficient consolidations. Then we can easy to differ efficient and the efficient server consolidation configuration. For example, if we consider the yellow server with the RX, we can see that having 6 virtual machines is more efficient than having 4 virtual machines in this case. Another use for this index is the comparison or the sorting of the different servers considering this index. As you can see in this table here, it's easy to sort the physical servers considering this index and the consolidation. So in this case, we can see that for this special case, the server Rx is the most efficient and is the most suitable for consolidation in this case, because the fees value in mean is the lowest. So another contribution of our work is that the performance degradation that determines the fees behavior, and this allows us to study also the server consolidation overhead. That is, not all the response time we consider in our experimentation comes from the execution of the real work. That is, we have an extra workload coming from the hypervisor and the allocation of the different number of virtual machines. So also in our work, we propose a method in order to estimate the amount of overhead we have in our consolidations. We obtain a different graphical representations, and as you can see in these graphics here, we have the useful work and the work coming from the different parts of the overhead, from the hypervisor, and also for the consolidation. The main conclusion here is that the consolidation of virtual machines and containers in virtual servers is not for free. The cost in this case depends on the hypervisor implementation, the physical resources, and also the number of consolidated virtual machines or containers we have. So to conclude, our first contribution was the fees index in order to quantify this trade-off between the performance degradation and the energy consumption. Then we can compare different servers in order to know which is more efficient in our case for the consolidation. Also, we propose a method to determine the consolidation overhead. And we are able now to quantify this overhead in order to perform the modifications we need in our servers in data centers. So that's all from my side. Thank you for your attention. And if you have any questions,